Hi everyone, this is Kona, and I'm going to talk about two-sample hypothesis testing with means. I'm also going to talk a little bit about one sample, just because I didn't cover everything last week, so we're going to cover a little bit this week as well. So basically, we've been working on comparing data from one group. This week we're going to start talking about comparing data from two groups. The biggest thing here is that they are actual means. So we are talking about numeric, actual number data, so no categories, we're talking numbers. The other thing is that we are still talking about basic tests, so we're talking about tests that only involve 1 to 2 groups or groups with 1 to 2 choices. So we're still basic tests that are numbers, no more categories. So the two types of two-sample t-tests are two-sample independent t, which responses in each group must be independent of each other, so unpaired or unrelated, so sample sizes may vary. And a paired samples were dependent t-test, and that's data on the two measures are matched, so the sample sizes are the same. So what do you think, independent or dependent? We randomly selected 20 males and 20 females, compared the average time they spend watching TV. Well, you might think, because we've got 20 and 20, oh, the sample sizes are the same, it must be paired. No, because the data isn't actually matched. We didn't match the men and women on any actual measure. So even though there are the same number of men and women, this is kind of a trick question, because even though the same number, it's actually a two-sample independent t-test, because technically these men and women have there's no relationship between them other than there happens to be 20 men and 20 women in the sample. So it is a two-sample independent t-test. We randomly selected 20 married couples and compared the time spouses spent watching TV. For this one, it actually is the paired samples because we're comparing the time for the spouses. So this is a pairing because a married couple is technically a pair. Granted, they've paired themselves, but whether it's a natural pairing or a self-selected pairing, it's still a pair, and it is 20 married couples. So in this case, it is the paired samples. We randomly select 6 females and 9 males and compared the number of hours they work per week. Well, the 6 and the 9 right there, they aren't the same, so that kind of immediately eliminates the paired samples, but also the fact that we're comparing the numbers of hours they work between men and women, which is kind of the categorical, and if you're comparing a categorical with a number, then it's always going to be that two-sample t-test here, like that. So it is the two-sample independent, and then we randomly selected 15 Math 113 students and compared pre-test and test scores. Well, this is a paired because we have the same 15 students and we have their pre-test scores and then their test scores. So the pairing is each student has a test and a pre-test score. So that's where the pairing comes in for the paired samples. So hypothesis for the t-tests, I went ahead and threw in the one sample because it wasn't there on the previous worksheet. Basically for these, the null is just the mean of the group is the same or equal to the claim value. The mean of one group is the same or equal to the other group. And the difference between the means are equal. So basically all of the nulls in this case are just all equality nulls. And that's for the one sample, the two sample, and the paired sample. The one sample t is just the mean of the group is greater than the claim value, mean of the group is less than the claim value, different from the claim value. For the two sample t, because you've got two groups, you've got the mean of one group is greater than the mean of the other group, the mean of one group is less than the mean of the other group, and the mean of one group is different than the mean of the other group. Now for the paired sample, dependent, now this is one where it might get a little confusing because what you're actually looking at is the difference between the means. So in this case, the difference between the means is greater than 0, the difference between the means is less than 0, and the difference between the means is not equal to 0. And that's because you're actually subtracting. So if you think about this one, pre-test and test scores, what they're actually doing to calculate this is subtracting pre-test minus test and then comparing that difference, so the amount of difference between the two. And so that's where it is greater than 0, less than 0, different than 0. So moving along, the test statistic is still basically observed minus expected over spread, where the difference is between the means of group 1 and 2. Spread is just your standard error. And we'll go into that, and we actually do go into that a little bit more for the quiz, but that's a completely different video. But just so you see this and you know what you're looking at when you get to the other video. So the steps for the two-sample hypothesis testing with means, and this is for independent and dependent, you check the necessary assumptions. For the two-sample, they must be independent, randomly selected, both populations must have a normal distribution. For the paired samples, samples must be dependent, so paired, randomly selected, and both must have a normal distribution. So in general, other than they must be independent and random, so for two sample they must be independent, and paired they must be dependent. The rest of the things we just kind of assume. So you don't really pay that much attention to these assumptions when we're actually in this class doing this. You write the original claim, so is it null alternative, which tail? Calculate the appropriate statistic, which in this case is, the test statistic is a t-value because we're in the t-distribution. Is there enough evidence? P is less than 0.05 is, P is greater than is not. Make a decision, null you reject, alternative you support about your original claim. So most of this is pretty similar to what we've done before. The only real difference is how we get that p-value and the t-value, which we will be doing using Minitab. So we will do some of this by hand, but most of it we are doing using Minitab. And so here are the directions, and I'm not going to go through those right here. Instead, I'm going to do these in a separate video, but you will use these directions for that video. So when you're wondering, where are the directions for this? Here are the directions, so you might want to print this off or have these available so you can kind of refer back to them. And that's it for this.